Hello, everyone. My name is Simon Platzer. I'm the Fall Protection System and Solutions Segment Manager in EMEA for MSC Safety. And today I would like to welcome you to our session, a CPD approved program, where we will discuss working at height, design, and the regulatory space. So we will be looking into the selection and the specification of compliant fall protection and what you need to know. So this seminar will cover fall protection systems for working at height from a legislative viewpoint. We will ensure you understand specification and installation obligations and liabilities, plus how to avoid some common misunderstandings which could impact safety. The primary focus is rooftop and horizontal fall protection. The purpose of this section is to establish MSA's credential in running the CPD and get the delegates familiar with both the MSA and Latchway's brand offer so that they feel confident they are hearing the message from the right people. With our global credentials. So MSA is a global leader in the development, manufacture, and supply of safety products that protect people and facility infrastructures with over 100 years proven heritage. Our global headquarters is based in Cranberry Township, near Pittsburgh in the US, with annual sales of approximately $1.2 billion and manufacturing operations in the United States, Europe, Asia, and Latin America, backed by R&D facilities in 3 continents. Our comprehensive line of products is used by workers around the world in a broad range of industries, including the fire service, oil and gas, petrochemical industry, construction, mining, and utilities. I think we are specialists in fall protection. So MSA acquired the Latchways brand in 2015 and established its Fall Protection Center of Excellence in the UK. The Latchways brand has always been a recognized leader in fall protection, and the origins of the product range goes back to 1974, when the Latchways founder, Commander Tupper, developed the Transfastener, a product that allowed yacht crew to walk around the boat whilst permanently attached to a fixed cable. The system was quickly adopted for use in the industrial sector as a complete hands-free fall protection solution. It was designed to work on buildings, inclines, vertically, around bends and corners. Nowadays, we still use the MSA Fall Protection Center of Excellence in the UK for our testings, for R&D actions, but also as a production plant. Last year, we made around 1,600 testings of our existing product range, but also of enhancements or of new developments to make sure that the products which are installed out in the field are perfectly tested and fit for purpose. In 2001, the Latchways Constant Force Post was launched, revolutionizing the installation of roof-mounted systems. The unique constant force technology was also incorporated into horizontal, vertical, inclined, and overhead cable lifelines. This is still virtually the only roof anchor system that supports the warranty across multiple leading roofing manufacturers. We'll see later why this is a very important fact. Hence why we and Latchways Fall Protection Solutions are specified and installed all across the world. And as you can see, with references going from Europe, from the O2 Skywalk or the London Eye, which is well known, over to the Pentagon and NASA workshop in the US, but also on the Bali Airport or the new Doha International Airport or Bangalore. So there are references all around the globe where people trust the solutions of MSA Safety. The purpose of this section is to explain legislative considerations for specifiers' responsibilities and what liabilities they may have if different products are used for a specification that haven't been tested to the same standard. Legislation is there to save life. The importance of working at height legislation cannot be underestimated, with falls from height still being one of the largest causes of workplace deaths and life-limited injuries. You are playing a vital role in helping eliminate that through better design safety measures and implementing to specification, both on new projects and retrofits. As professionals, You must understand the workplace health and safety regulations as they relate to work at height. It is important that as designers, you ensure that you take up your responsibilities during the project design stage and to facilitate continued safe access on buildings throughout their lifetimes. This also includes providing method statements detailing how the provision of safe access can be achieved. On the screen, you can see the Occupational Safety and Health Act from 1994. We will now look into Task 17 and Task 18, which are general duties of employers and self-employed persons to protect persons other than their employees, and the duties of an occupier of a place of work to persons other than his employees. Let's look into Part 4, General Duties of Employers and Self-Employed Persons of the Occupational Safety and Health Act in 1994. Clause 17 clearly says, it shall be the duty of every employer and every self-employed person to conduct his undertaking in such a manner as to ensure, so far as is practicable, that he and other persons not being employees who may be affected thereby are not thereby exposed to risks to their safety or health. Additionally, we'll also look into Part 5, Clause 18, which clearly says, a person who has, by virtue of a contract or lease or otherwise, an obligation of any extent in relation to the maintenance or repair of a place of work or any means of access thereto or egress therefrom, the prevention of risks to safety and health that may arise from the use of any plant or substance in the place of work. So, the key points for working at height are: you must document in the health and safety plan your fall protection strategy for managing all hazards and risks throughout the whole design phase through the occupation of the building, and then supporting any ongoing work such as building maintenance and cleaning. Clarity on who is responsible for life. The principal designer is responsible, and if there are multiple contractors, one principal designer and one principal contractor must be nominated. And what you can see on the screen is very, very important. Based on the Department of Statistics of Malaysia's official portal and reports of 2020, falls of persons are still the main cause of accidents, with 7,885 falls happened in 2020. So whilst we can see people wearing hard hats, people wearing safety boots, and many other PPE measures all over the place, falls of person are still an underestimated risk, but being the largest root of accidents in 2020. So there are some CDM considerations for fall protection, which principal designers must be considered to be confident. Roof types affected the design and fixing method. Take secret fix roofs, standing seam roofs and warm flat roofs, for example. The anchor will perform differently on different materials when forces are exerted. Check that the system you use has been tested in the way you need, which means a representative testing on the roof structure itself. Many contractors substitute like for like, but need to reject the suitability for use on a specific roofing system. This is one of the main reasons it is important that a manufacturer tests on every roof type their system will be fitted to. If the equipment you have specified is changed without your knowledge, you could be held legally liable in the unfortunate event of an accident. Energy absorption technology means that in the event of a fall, systems deploy in a controlled manner to absorb the force generated. In doing so, it ensures that the load exerted on the point of attachment will not exceed 10 kilonewtons, and so allows the post to be fixed to a relatively delicate structure without the additional requirement to attach to structural steel or purlins. This ensures the roof or structure remains intact and workers are kept safe, even in the event of a fall. Let's go to the next section of our today's session. This purpose is to explain legislative considerations for specifiers and what liabilities you might have. The hierarchy of fall protection helps your structure your planning from the outset. So the hierarchy is, wherever possible, firstly, eliminate the risk. Next, where you cannot eliminate, guard the hazard. And finally, protect the worker. The fall protection solution specified should be based upon the area requiring access, the frequency of access required, the number of people needing access to the area, and the level of training these people have gone through or will undertake. For instance, we can choose both collective and personal fall measures to prevent a fall. Similarly, we can implement personal safety measures then that can reduce the consequence of a fall. Again, we are looking into the hierarchy of falls or risks. First of all, we want to eliminate or substitute the risk as much as we can. If we can work from a ground level or substitute the maintenance process completely, then we should be doing so. If that's not possible, we should be looking into passive fall protection. So we want to guard the hazard by isolating or separating the hazard from a workspace. If that's also not an option on your project, then please let's go into the personal fall protection hierarchy, which means, first of all, we should always try to make sure that a fall restraint system is applicable on site. So that secures the workers using a short lanyard enough to protect the worker to fall from the edge. And due to certain challenges on projects, we might have to go to the last phase, which is a fall arrest system. In that case, we will have to make sure that we have a suitable system and a suitable product selected, but also incorporate the right rescue procedures. Let's look at system choices. Collective protection is any system that allows numerous untrained users to access an area whilst being protected them from fall hazards, without the need for personal protective equipment such as harnesses, retractables, or lanyards. Once properly installed or erected, collective protection does not require any action by workers or specialist trainings to keep workers safe. There are a number of detailed criteria to be taken into account for collective protection, such as the parapet minimum height, the upright handrail spacing, the roof area where it's installed, and the standards it has to comply to. Personal protection systems safeguard individual users from risks associated with working at height and are often specified when a collective system is not necessary or possible. There are two categories of personal fall protection systems, as we've seen before. It's fall restraint and fall arrest. Often the generic term fall arrest system is used for both types, but there are critical differences to understand between them. The safest version of a personal protection system is a fall restraint system, where each worker wears a full body harness and a lanyard connecting them to a horizontal lifeline system or an anchor point, which are anchored to the building or structure. The lanyard length is fixed, so the worker cannot reach any fall hazard. With no need for lanyard adjustment, only basic training is required. A fall restraint system should always be designed to used with a fixed 1.8 meter long lanyard, keeping users from accessing any fall hazards, and should always accommodate 2 people as a minimum to ensure safe working practices are adhered to. In some instances, it's impractical or, unfortunately, impossible to design a fall restraint system, and there are fall hazards which cannot be eliminated or avoided, such as roof lights. These cannot always be guaranteed to be safe to walk on. In situations like this, a fall arrest system is required. This means that fall hazards can be reached by a worker on a fixed or variable length lanyard when they are secured in a lifeline system. A fall arrest system must have restricted access, and personnel using this system must have undergone specialist training to safely secure and adjust their personal protective equipment. For example, some routes may require the use of two lanyards to safely navigate into areas requiring access. Like the fall restraint system, a fall arrest system must be designed to accommodate a minimum of two workers, as there is an additional requirement for a rescue plan to be in place should a fall occur and user be suspended in their harness. Let's look at the differences in system designs. In rooftop applications, generally a designer must select a perimeter or a ridge system. The first system shown here is a perimeter system with which the user connects immediately to the roof access location and has full movement around the roof perimeter or edging, whilst remaining in fall restraint at all times. The second option shown is a ridge system, which also uses additional single-point anchor posts to allow users to access the roof corners. This type of system requires a comprehensive level of user training to ensure that adjustable personal protective equipment is used the correct way. In both instances, but particularly with the ridge system, the designer must check that the system specified has been tested and approved to be a fall arrest system. So let's go on to understand more about the test standards for fall protection systems. The purpose of this section is to highlight the key standards which need to be adhered to and explain what testing is covered and where specifiers need to be cautious in terms of the testing so that they can make the right system or product choice. First of all, we'll be looking into the guidelines for anchors. According to guideline, how many kilonewton of force must a single person fall arrest anchor be able to withstand? You can guess now, and I will tell you it's 15 kilonewtons. Let's go to the next one. According to guideline, how many kilonewtons of force must a two-person fall arrest anchor be able to withstand? Guess again. It's 21 kilonewtons, so we're talking about 2,100 kilograms. And last but not least, according to the guideline, the minimum ultimate strength for rope use in industrial rope access is how much? It's 25 kilonewtons. So we're talking about 2,500 kilograms, which needs to be the ultimate strength for rope use in industrial rope access. And these kind of examples show you that the loading per person, even if we are only considering the PPE, is applicable to 100 kilogram or possibly 120, 140, the anchor itself must withstand a lot more to really protect the worker in event of a fall. So what are the designer's concerns about safe design legislation? The surveys conducted by Safe Design Australia show that the main concerns that designers have with the safe design legislations are due to the following reasons. Largest part being lack of knowledge. Knowledge of safe design is relatively low industry-wide, so the majority of designers have no formal education in this area. Please make sure that if you believe that you're lacking knowledge, you will always contact experts to ask for support. But it's also the lack of knowledge with legislation and how these improve the safety of workplaces. Legislations are changing, norms are changing, so please make sure that you attend proper CPD webinars on occasions to make sure that you're always up to date to the latest standards. But then it's also the restrict creativity. With safety, it's quite important that we always design and install fall protection products as per the manufacturer's guidelines. So creativity is there to ensure that design solutions to identified hazards are implemented without compromising the design intent. So the designer must ensure, so far as is reasonable practicable, that the structure is designed to be without the risk to health and safety of persons who manufacture or construct any component of the structure, who use the structure for the purpose for which it's designed or are involved in the maintenance or disposal of that structure. The term reasonably practicable is also used in relation to consultation with other duty holders and between designers and clients on how risks to health and safety during construction can be eliminated or minimized. Reasonably practical means that which is, or what is at a particular time, reasonably able to be done to ensure health and safety, taking into account and weighing up relevant matters including the likelihood of the hazard or the risk concerned occurring, the degree of harm that might result from the hazards or the risk, what the person concerned knows or ought reasonably to know about the hazard or risk and ways of eliminating or minimizing the risk, the availability and suitability of ways to eliminate or minimize the risk, and after assessing the extent of the risk and the availability of ways of eliminating or minimizing the risk, the cost associated, including whether the cost is grossly fine to the risk one. So let's look into the safe design of structures. First of all, we will start with prevention. So make decisions at concept design stage to eliminate or minimize hazards at the source. Then we'll be thinking of the life cycle. Consider the safety of the structure during its life cycle, including construction, maintenance, use, and demolition. Then we'll go through a systematic assessment. Apply a systematic approach to hazard, ID, and risk assessment to identify hazards that are within the control of the designer and that are not specifically addressed by a recognized standard. Consult, test, and control. Use creative design, knowledge, research, testing, and consultation to eliminate or minimize hazards within the designer's control. Review during design development and construction documentation stages. Then we'll transfer the information to all stakeholders throughout the life cycles, identify residual risk to be managed by other stakeholders, and then we'll review the process, we'll receive feedback, and seek for continuous improvement. For designers, safety in design provides a system to formally document a process demonstrating systematic risk management. For client, cost savings may be found in preventing future retrofitting and downtime. Insurance premiums may be reduced as well as the risk of litigation. Occupiers may see benefits in reduced injury management interventions, increased usability, reduced maintenance costs, and improved productivity. So again, these are all the benefits of safe design. Yeah, there are a number of duty holders who have roles in the safe design process. These include architectural designers, other designers, including engineers, plant designers and manufacturers, the client, the workers, the users themselves, and the principal contractor. So it's all about consultation, cooperation, and coordination of the design process to minimize the hazards, but also throughout the complete installation and the life cycle of the products. As a specifier, you cannot assume that a 1997 tested system will be capable of withstanding two people falling on it. If it isn't, it will fall short of today's standards. The 1997 standard didn't adequately cover restraint systems. The 2012 standard specifically covers restraint system and possible misuse. For example, if the incorrect lanyard length is used, so a fall hazard then becomes accessible. That's how we would see it in Europe. And if we would be looking into the Occupational Safety and Health Act of 1994, systems must meet the requirements under Australian New Zealand Standard 1891.4 from 2009. So it covers both the fall arrest and the fall restraint as a work position. The tests are including fixings and base materials, and multi-user devices must support at least 2 users falling simultaneously. So it's really leave nothing to chance. So which standard has the products you're specifying or you want to use been tested to? Which materials has it been tested with? And are multiple users covered? And yeah, what we have to make sure that the duty holder is aware of is that all the PPE choices satisfy the new test requirements. So we are not only talking about the installed products, which you would specify, it's also the PPE compared to the systems themselves. So how can you be sure the fall protection system is guaranteed for the application and the structure? When it comes to particular manufacturers' roof systems, a non-approved fall protection solution installed on a roof could invalidate the roof warranty. Ensure that when a certain roof system is specified, check with that roof manufacturer if there is a particular fall protection system that they have forming part of the guarantee. It's worth remembering this when considering any future roof issues, that if a non-approved fall protection system had been installed, it may well invalidate the roof warranty or guarantee. Again, you need to go through the same due diligence process when looking at temporary edge protection to construction as you would for permanent protection for ongoing building access. So, again, if we think back of the system testings and standards, we are mainly considering 4 roof types, which being trapezoidal buildup on site and composite panels or sandwich panels roofs. We're looking into membrane, which is most of the time a flat roof, which could be a reinforced concrete structure, insulation and waterproofing, or it could also be a trapezoidal deck or a timber deck. Then we're looking into standing seam, including secret fix and folded seam. And these are the main roof types we would be seeing in all global markets. So if we look into how testings can be performed, we were also thinking of the Australian New Zealand standard 1891-2 2001 and Australian standard 1891.4 2009, which covers industrial fall arrest system and devices and is the part 4. You have to be aware of the huge amount of energy that is created when a fall is halted or arrested by a fall protection system. Generally, a new roof construction may only be capable of withstanding somewhere around 25 kilonewtons or approximately 2.5 tons of force, so a fall protection manufacturer must look to reduce the loads going back to the roof structure to way below these figures. Energy absorption technology within a fall protection roofing anchor reduces the possibility and the load back to the roof to 10 kilonewton. And even with a factor of safety of 2 resulting in 20 kilonewton, this is still easily below the failure point of a new roof construction. If a fall protection product is not tested for its load absorption capacity, huge forces can be applied to roof construction in the event of a fall. This may result in the roof failing or coming apart in some way. We've already gone through representative roof testing and also the importance of checking for roof manufacturing approval. Also ensure that the product you're specifying works in any direction, as realistically there is no way of foreseeing which way a fall might occur on a system. Remember to check that the system will work for the intended number of users for its anticipated use, and also as a good practice for avoiding lone working. All tested products should carry clear product markings according to the standards. This ensures that the post clearly displays the manufacturer details and what standard the product has been tested to. It's a good practice for a safety product to be made from quality materials to ensure durability. And whilst products might not only be applicable to Australia and New Zealand standard 1891, they might also be EN 795 compliant, which means The European standards for fall protection products, and especially for installed fall arrest systems with their types A, B, C, D, E, make sure that your product is not only covered by one standard, but in the best case covers multiple standards all around the globe. And as you've heard a couple of times through my presentation, energy absorption is something very, very important. What you could see here is a test of a 150 kilogram person or weight falling into an anchor. Without the energy absorption, we could not make sure that the roof structure itself would withstand the loading and could potentially fail. Therefore, please make sure that all the products you would specify and you would use do have an appropriate load absorption integrated. So this section runs over a series of other working at height considerations, from material considerations, walkways, ladders, window maintenance, etc. Roofing systems must often provide maintenance access to a variety of equipment. This image represents just some of the scenarios in which fall protection is required, such as window cleaning, plant maintenance, solar PV maintenance, are just some of the working at height challenges that leading fall protection manufacturers can safely overcome. But it's also that not every project considers the 4 main roof types we've been discussing before. It's also bespoke systems. So bespoke engineered systems are a very, very important and crucial point for every fall protection manufacturer, but also for yourselves as a specifier and designer. Please make sure that if no standard product can be used, that you consult manufacturers directly to make sure that the new product or the bespoke product covers the variety of standards, but also is safe to use in the event of a fall. Many rooftops are accessed using a fixed ladder. This can create further fall risks. So it's not only the rooftop itself and the edges or roof lights, it's also the ladder to get up to the roof. The Health and Safety Executive confirms that ladder hoops offer no positive means of fall protection. In fact, they can be harmful should someone fall and strike the hoops. The preferred industry option is a central rung-mounted cable lifeline system. Whether installed onto an internal or external ladder, workers have the flexibility to use both hands to climb, whilst remaining safely attached. Unlike hoop systems, cable lifeline systems present no obstructions that could cause serious injuries while arresting a fall. For fall protection in larger spaces, such as factories and car rail, loading bays, self-retracting lanyards can connect to an overhead lifeline cable. Automatically extending and retracting, they offer non-intrusive protection. SRLs remain taut, don't impede movement, and keep hands free to work. In certain building designs, access from inside is needed to carry out external work. For instance, external window cleaning and maintenance. Legislation for this sits within the CDM regulations of 2015 from the UK. Eye-bolts are commonly used, but both bolts and fixings need to be able to withstand the loads generated when a fall is arrested. For correct performance, installation must comply with EN 795, but also with British Standard 7883. Regulation 4 of the Work at Height regulations state that every employer must ensure that work at height is properly planned and that planning of work includes planning for emergencies and rescue. Employers must have a specific and planned rescue method. The use of emergency service is not an option. There is a legal obligation to ensure any casualty is attended and recovered quickly. Products are available which incorporate the personal descent device. In the event of a fall, the harness will not only arrest the fall but also allows the workers to initiate their own rescue. Pulling a parachute-style released cord lowers them up to 20 meters to ground clearance in gently less than 30 seconds. Even if suspended and unconscious, a collie can safely activate the release with a specially designed pole using the secondary descent mechanism. The benefits of such product is that they are simple and there is no complex, costly training course needed. Efficient, no supervision rescue team needs to be on standby. It's productive and instant self-rescue minimize disruption, downtime, and safer, as no rescue is needed. It means there is no risk to anyone else. What you can see now is the person, after his or her fall, will activate the rescue mechanism and will therefore descend safely to the next structure down below. So let's wrap up today's course and let's go for a quick summary. Having gone through this seminar, you should now be able to appreciate how legislation attributes responsibilities for the provision of safe access. You should be aware of elements you need to consider when choosing and specifying a fall protection system and the ways it can be integrated within the building designed to be compliant. You will be able to difference between collective and individual protection, between fall arrest and fall restraint. You will be able to specify the correct system based on the varying competence levels of individuals using the different systems and be able to demonstrate that the system is fit for purpose. You're now aware of the major changes to testing standards for fall protection equipment and their impact on choosing products. And you've seen how solutions can help with challenges like maintenance and rescue. If you have any queries, leading fall protection manufacturers can help you with the design of your fall protection systems. If you have any questions to us, please make sure that you click on the button below to view our virtual stand. And please make sure that you get in touch with our local fall protection system team. Thanks again, and I'll wish you a great day ahead.